Well, hello everyone. This is the demonstration for the first three questions in the 2020 Thanksgiving break problem set. For the first question, it asks about the integers that will actually about the 8 positive integral factors, which is about 30. This is a very straightforward problem that only has one star. So you just have to first factor out 30, then you will get a 2, a 3, and a 5. And by doing this, you could find the factors of 20, like with 1, 2, 3, 5, 6, 10, 15, and 30. And when you are multiplying all of them together, which in this case, you are multiplying 1 and 30, you get 30. When you're multiplying 2 and 15, that's also 30. Also the same as 3 with 10 and 5 with 6. When you are multiplying all of them together, you will have, as a result, have the 30 to the fourth power because you are multiplying four 30s together. This shouldn't be a challenging question for you. And for question number 2, asks about the common multiply of the positive integers. So first it gives you a definition of 1, 2, 3, 4, 5, in which the first five positive integer, their common multiplier would be 60. In this case, you multiply 3, 4, and 5 together. You are not multiplying 2 here because when you're having 4, you can treat it as 2 multiplied by 2, and it already included two 2's here. So it has already included this 2, so you don't need to include it anymore. So in this case, you're multiplying 3, 4, and 5. And when you're going down to the second scenario, like when you're having 2, 4, 5, 6, like at the same when you're having 4, you do not need to multiply 2. And as you're already having 3 and 4, you don't need 6 anymore because 6 is 2 multiplied by 3, and you've already included 3 and 4 in this. So when in this case, you will still multiply 3, 4, and 5 together, which gives you 60. This is the same as the multiple of the common multiple of the first five positive integer. About question number 3, you are actually it's actually about some divisor problems. And for this problem, by the information from the question, you could find that the quotient, like when you are dividing x by y, so the quotient is 3 and the remainder is 7, so you will get this one. And when it's saying that you divide y by x, the remainder is 12, you could get this one. And you need to have some simple conversions to the right. So you will have x equals 3y plus 7 and y equals kx plus 12. When you're having all of them there, here you need to remind for one thing, like when you are having the remainder, the remainder should not be greater than the quotient. So that means y is less than y is greater than 7, and here x is greater than 12. When you are going down, you just need to plug in this y into the upper function, which will gives you x equals 3 times parenthesis kx plus 12 parenthesis ends plus 7, which when you are expanding this part, you will get x equals 3x plus 43. In this case, when you are doing some other algebra conversions, you will find 1 minus 3k times x is 43. And you will find that 43 is actually a prime number. As a prime number, when it's 43, it's either being 1 times by 43 or 43 times 1. So either your x would be 43 and your 1 minus 3k would be 1. And or you could have the x being 43 and this one being 1. And from here, you can actually see that the k should be positive and x should be greater than 12. In this case, you will have 1 minus 3k as 1, in which k equals 0, and in this case, consequently, x will just be 43. So the value of x will be 33.